Hello and welcome to the fourth and last part of the training program on fan and blower. Hi, I'm Rahul. Hope you have learned a lot about fan and blower, its parts and performance in the previous modules. In this module, we will learn about its maintenance.
In the end of the module, you will be able to explain about maintenance safety guidelines, elaborate on motor maintenance, drive maintenance and bearing maintenance, explain wheel and shaft maintenance and structural maintenance, describe troubleshooting of fan and blower, describe daily checkpoints and monthly checkpoints.
Fan and blower maintenance safety guidelines. Every device requires maintenance, and when it comes to fan and blowers, knowing about maintenance is a very crucial part of the training program. Let's learn about the maintenance safety guidelines. Any maintenance requiring the guards to be removed shall be performed while the fan is not operating. The rotor and all drive components that are free to move must be properly locked in place before obtaining access to those parts. Maintenance personnel should take the proper care to ensure that no items are left behind that could be drawn in and ejected from the fan. Anything dropped into the fan must be removed before starting. Lockouts shall be used whenever unexpected energizing of the fan could cause a mechanical or electrical hazard. Only personnel trained in the hazards and risks associated when installing, operating and maintaining fans shall be allowed to dismount any guards or access doors. Proper care should be taken so that no hardware is lost during maintenance. In the maintenance part, first we are going to learn about motor maintenance. The three basic rules of motor maintenance are: first, keep the motor clean. Second, keep the motor dry. Third, keep the motor properly lubricated. Blow dust off periodically with low pressure air to prevent motor from overheating. If the motor is to be started after sitting for more than a week, the resistance of the motor windings to earth should be measured. If the resistance is less than that given in the manufacturer's manual, the motor should be dried until a resistance over the values given in the manufacturer's manual is measured. Some smaller motors are lubricated for life. Lubrication requirements are normally attached to the motor. Use the motor manufacturer's recommendations for re-lubrication. If this information is not available, the following schedule may be used. Motors less than 10 horsepower running about 8 hours a day in a clean environment should be lubricated once every 5 years. Motors 15 to 40 horsepower every 3 years. For motors in dusty or dirty environments or running 24 hours a day, divide the service interval by 4. Do not over-lubricate. Note that motors typically use a different type of lubricant than fan shaft bearings. Next, we'll discuss about drive maintenance. V-belt drives need periodic inspection, retensioning and occasional belt replacement. Proper belt tension can be found on the included data sheet specific to each fan. A log should be kept with belt tension and replacement information. Let's discuss about bearing maintenance. Proper lubrication of the fan drive bearings helps assure maximum bearing life. All fans are equipped with information indicating re-lubrication intervals for normal operating conditions. Bearings should be inspected after the first 24 hours of operation and then inspected each time they are lubricated. Lubrication schedules for the included type of bearings are attached to the fan. Note that all speeds shown do not apply to all shaft sizes in that group. Consult the factory if in doubt of maximum speed for a particular bearing. Note that every installation is different than the frequency, and the frequency of re-lubrication should be adjusted accordingly. On high moisture applications, the lubrication frequency may need to be doubled or tripled to adequately protect the bearings. Double the re-lubrication frequency on fans with vertical shafts. Observation of the conditions of the grease expelled from the bearings at the time of re-lubrication is the best guide as to whether re-greasing intervals and amount of grease added should be altered. Greases are made with different bases. There are synthetic base greases, lithium base, sodium base, etc. Avoid mixing greases with different bases. They could be incompatible and result in rapid deterioration or breakdown of the grease. The lubrication sticker identified a list of acceptable lubricants. When the fans are started, the bearings may discharge excess grease through the seals for a short period of time. Do not replace the initial discharge because leakage will cease when the excess grease has worked out. Sometimes the bearings have a tendency to run hotter during this period. This is no reason for alarm unless it lasts over 48 hours or gets very hot, over 200 degrees Fahrenheit, 93 degrees Celsius. If bearings are exhibiting excessive vibration at any time or are running hotter than 200 degrees Fahrenheit, 93 degrees Celsius, the bearings should be inspected for proper lubrication, alignment, tightness of set screws, cap bolts and collars, and inspected for signs of contamination in the lubricant. The bearings or damaged bearing components shall be replaced if found faulty or showing signs of wear. When re-lubricating, use a sufficient amount of grease to purge the seals. Rotate bearings by hand during re-lubrication. Next, we will learn about wheel and shaft maintenance. Inspect the shaft and wheel for dirt buildup, corrosion and signs of excess stress or fatigue after 1 month of service. Future inspection intervals shall be based on findings in this initial inspection. Clean the components. If any signs of damage, stress or fatigue are present, deformation, cracks, excessively worn surfaces, the part shall be replaced. Any material builds upon rotating parts or parts that could contact rotating parts shall be cleaned. If the wheel is removed for any reason, make sure that it is securely attached to the shaft before restarting the fan. The wheel and shaft shall also be inspected any time if excessive vibration is observed and if the vibration level is expected to be beyond manufacturer's limit. All structures need maintenance. Let us learn how to carry out maintenance of structures. All structural components or devices used to support or attach the fan to a structure should be checked at regular intervals. Vibration isolators, bolts, foundations, etc. are all subject to failure from corrosion, erosion and other causes. Improper mounting can lead to poor operation characteristics or fan fatigue and failure. Check metallic components for corrosion, cracks or other signs of stress. Replace any components showing any of these signs. Concrete should be checked to ensure the structural integrity of the foundation and repaired or replaced if any signs of damage are found. Where the fan is used to handle toxic gases or vapors, the housing and wells shall be inspected for signs of corrosion or cracking at regular intervals to assure no toxic gases can escape. The condition of the coating shall be inspected as well to verify the bare parts of the fan are not exposed. All gaskets and ducting shall be inspected for signs of erosion as well. The initial inspection after 1 month of service shall be used to determine an appropriate inspection interval. We had quite a lot discussion on the maintenance of fan and blower. But what if machine fails or a part of it stops functioning properly? Troubleshooting would be required, right? So, let us now discuss troubleshooting of fan and blower. Click on each to know more. First topic we would be discussing is excessive vibration and noise. If there is excessive vibration and noise, check for the following: loose mounting bolts, bearings and sheaves, misalignment of sheaves, motor or internal bearing, belts too loose, worn or oily belts, speed too high, damaged or unbalanced wheel, bent motor or blower shaft, bearings need lubrication or replacement, fan surge, incorrect direction of rotation. Make sure the fan rotates in same direction as the arrows on the motor or belt drive assembly. Material on fan or blower wheel blades, loose fan housing or foundation bolts, vibrating ducts, foreign material in fan housing, inadequate structural support, support structure not sufficiently cross-braced, weak or resonant foundation, foundation not flat or level. First topic we would be discussing is excessive vibration and noise. If there is excessive vibration and noise, next is low capacity or pressure, poor fan inlet conditions, there should be a straight clear duct at the inlet. Incorrect direction of rotation, that is opposite to the direction recommended by the manufacturer. Make sure the fan rotates in same direction as the arrows on the motor or belt drive assembly. Improper wheel alignment, motor RPM too slow, dirty fan blades, actual system has more resistance than designed for, dampers are closed, leaks in duct work, dirty or clogged filters in air cleaning device, obstructed fan inlets causing system effects, no straight duct runs at fan inlet or outlet, improperly designed duct work, fan not getting adequate makeup air. Moving on further with the topic of troubleshooting, let's learn about excessive airflow. If there is excessive airflow, check for the following: access door open, filters not in place or tears in filters, system resistance low, motor RPM too fast. Overheated motor. If there is excessive airflow, check for the following: motor improperly wired, cooling air diverted or blocked, improper inlet clearance, incorrect fan RPM, incorrect direction, overheated bearings. Sometimes problems can be caused due to overheating of bearings. If there is overheating of bearings, check for the following: Improper bearing. Fan does not operate. Sometimes fan ceases to work properly. If so, check for the following points: blown fuses, broken belts, loose pulleys, electricity turned off, fan impeller touching housing, wrong voltage, motor too small, overload protector had broken circuit, low voltage, fan load too large for motor, seized bearing. Fan does not operate. Moving forward, now we are going to learn about the various checkpoints associated with fan and blowers. We'll discuss daily checkpoints as well as monthly checkpoints. First, let us learn about the daily checkpoints. Shown on screen are the various checkpoints which are to be monitored on a daily basis. Click on each to know more. First, temperature. Frequency shift. How to check? Use temperature gun and scan on the bearing plumber block or housing for maximum temperature found. Criteria. As per previous reference, in good condition. Action if out of criteria. Sudden increase in temperature by more than 5 degrees Celsius should be taken in notice and reason should be analyzed. Second, noise. Frequency shift. How to check? By observation. Criteria: no abnormal noise. Action if out of criteria. Use engineer's stethoscope or hearing rod. Third, base bolts. Frequency shift. How to check? Observe for mismatch in match mark of bolts. Criteria: no mismatch. Action if out of criteria. Tighten the bolt by proper torquing. Fourth, coupling guard. Frequency shift. How to check? Coupling guard fixed in the place. Criteria: coupling guard should be fixed at the place and no looseness. Action if out of criteria. Place the guard in the place. Last, oil leakage. Frequency shift. How to check? Leakage drop by drop, alarming. Criteria: no leakage. Action if out of criteria. Check for seal damage and replace it. Let us learn about the checkpoints that need to be taken care on a monthly basis. Click on each to know more. First, vibration at all bearing points. How to check? Use vibration meter. Criteria: as per previous reference, in good condition. Action if out of criteria. Find the root cause by spectrum analysis. Second, temperature at all bearing points. Criteria: as per previous reference in good condition. Action if out of criteria. Sudden increase in temperature by more than 5 degrees Celsius should be taken in notice. Check lubrication condition and check bearing condition. Third, any abnormal noise. How to check? By careful observation and using engineer's stethoscope. Criteria: no abnormal noise, no abnormal hissing sound, whistling sound, knocking or rubbing sound. Action if out of criteria. Abnormal rubbing sound, shrill, knocking, etc. to be checked for rectification. Fourth, motor and casing base bolt. How to check? Visual match mark on nut and bolt. Criteria: no looseness or missing bolts. Action if out of criteria. To be tightened or fixed. Let us learn about the checkpoints that need to be taken care on a monthly basis. Click on each to know more. Fifth, coupling bolts. How to check? Visual inspection. Criteria: no looseness or missing bolts. Action if out of criteria. To be tightened or fixed. Sixth, looseness in bearing pedestal bolt. How to check? Visual match mark on nuts and bolts. Criteria: no looseness or missing bolts. Action if out of criteria. To be tightened or fixed. Seventh, fan casing. How to check? Visual inspection. Criteria: no hole and cracks. Action if out of criteria. To be rectified. Seventh, fan casing. How to check? Visual inspection. Criteria: no. 8. Other missing components like guard, plug, gauge, proximity switches. How to check? Visual inspection. Missing proximity, missing split pin. Criteria: no missing components. Action if out of criteria. Rectify the missing components. Now that you have completed the module, it's time for you to check your knowledge by answering these questions.